Hi students, today we are moving on to solving quadratic equations that can be factored. So first of all, we need to know or establish what a quadratic equation is. We use quadratic equation as a term when sometimes we actually mean an expression or a relation. So let's look at the difference between these three. So a quadratic expression could be something like x squared plus 9x plus 14. Okay, it's quadratic because it's of degree 2, and it's an expression because there's no equal sign. It's not equal to anything. A relation is when we talk about a general quadratic like this. So it's y equals x squared plus 9x plus 14. So this is an entire quadratic relation. We can graph what it looks like. It would be represented by a parabola, and we can find a set of points that are on this relation. Any x or y that would satisfy this relationship are part of the relation. A quadratic equation is different though. You take your quadratic expression and set it equal to a number. So that number could be 0, it could be 2, it could be -5, it could be root 10, it can be anything. And quadratic equations are solvable. Okay, there can be 2, 1, or no solutions. So solving a quadratic equation means finding the x value, or in this case, it could be multiple values. So the x values that result in the given y value. So solving this equation means finding x values. So x values on find x values that make left side equal to 0 in this case, because we want to set it equal to 0. So if we look at this graphically, this is the parabola where its relation is y equals x squared plus 9x plus 14. So solving where it equals 0 is equivalent to finding those x values that are where y equals 0. So in this case, x equals -7 and x equals -2 are both solutions. Okay, in both cases, if I sub in -7, so if I do -7 squared plus 9 times -7 plus 14, if you put that into the equation, it would give you 0. Similarly, if I put in -2, so -2 squared plus 9 times -2 plus 14 is also equal to 0. Both these x values, when subbed into the equation, give a y value of 0. No other x values in the entire world do that. So you can actually get your calculator out and test it if you'd like. So you can also have a quadratic equaling a number other than 0, as is the case here with this one. So 6x squared minus x equals 15. So algebraically, that means what x values make the left side equal to the right side. In other words, make this left side equal to 15. So the parabola I sketched here is y equals 6x squared minus x. And you can see here is the line where y is equal to 15. So similarly, you can see there's 2 points where the parabola is equal to 15. And if you know how to solve it, which we will solve it algebraically on the next page, you can actually find that this is 5/3, and this x value is -3/2. So -1.5. So this means if you put in 5/3, so 6 times 5/3 squared minus 5/3, you would actually get exactly 15. Similarly, if you put in negative 3 over 2 into the equation, you would get 15. So both of these are solutions to this equation. So x equals negative 3 over 2 and 5/3 are the solutions to that equation. So that is the first important part, is just understanding what it means to solve a quadratic equation. So now we're going to look at how we actually do this. So one way is by using GeoGebra or some other software. So if we go here to the graphing, actually here, I can type in the relation y equals x squared plus, get down here, plus 9x plus 14. Okay, and press enter. And then I can, because I want it to be 0, I can put y equals 0 as the other line. And notice that GeoGebra instantly gives me these points of intersection. So if I click here, it gives me -7, 0, and -2, 0. So the graphing calculator can do that. Now, there's another really good feature on GeoGebra. If you go under classic apps here, where it says CAS, it will give you this screen. So here you can actually put an equation in. So x squared plus 9x plus 14 equals 0. Now don't press enter. We want to go to this x equals button. The wavy equal sign means approximate. So if there is a fraction answer, then this would give you the decimal. But in this case, we want the actual exact number. So we click this and it solves it for us. X equals -7 and x equals -2. Thanks, technology. So this is what you should be using, the graphing and the CAS, the computer algebra system, to verify things in any of your conversation or other assignments. Anytime you have an opportunity when it's not in a test, the best way to improve your thinking marks and show your critical thinking and reasoning is through verifying using technology. So I'm always looking for that when I mark your conversation assignments. So back to the note, how can we actually do this though with pencil and paper? Well, one common method is factoring. You might be thinking, why does factoring help? Well, notice this. In this equation, we want to know when this is equal to 0. But we can't collect like terms like we're used to with linear equations. Remember, with linear equations, if I had 3x plus 5 equals 2x minus 1, I would just move this x over here and this 5 over there, and I would solve for x and everything would be good. But with quadratics, we have an x squared and an x that are not like terms. And notice here that this is what I like to call an addition sentence. So in this equation, it's saying what 3 numbers add up together to be 0. Well, there's any endless number of combinations of 3 numbers that can get you to 0. So what we want to do is turn it into a multiplication sentence that equals 0. Because if you multiply things together, you know that one of the factors has to be 0 in order for the product to be 0. So that's why factoring works. So this is a simple trinomial. So we just look for the numbers that multiply to 14 and add to 9. So that is x plus 7 and x plus 2 equals 0. Now notice I carry down the x equals 0 because it is an equation. This is all part of the equation. So now I know that either this product has to be 0, or sorry, this factor has to be 0, or this factor has to be 0. That's the only way for you to have something times something equals 0. So I can solve that x is equal to -2 or x is equal to -7, as I did graphically and as I did using technology. So let's try another one. 2x squared plus 5x equals 0. Again, we cannot collect like terms, so what we are going to do is factor. And you might say, well, Mrs. Weens, this isn't a trinomial. Don't forget common factoring. Okay, it's still, it is useful and you will be using it to solve equations. So in this case, I can common factor out an x, and then I'm left with 2x plus 5. I know I'm fully factored because in this bracket, there are no more common factors. So now either this x has to be 0 or the 2x plus 5 has to be 0. So now I just isolate x. So 2x equals -5, or x equals -5 over 2. So my solutions to this equation are x equals 0 and -5 over 2. So in both of those examples, we already had a quadratic expression equaling 0. In this example, we have a quadratic expression equaling 15. Okay, so we can't isolate x because there are no like terms. All right, so we can't, usually we're used to moving all the numbers to one side and all the x's to one side, but that doesn't help us here. We can't do anything else with the left side. If you leave the equation like this, in this form, factoring doesn't help. So imagine I did common factor out an x, and I'm left with 6x minus 1 equals 15. Well, this would mean that two numbers have to multiply to 15. This isn't really helpful for us because there's an infinite number of numbers that actually multiply to 15. Sure, you might be thinking, oh, it's only 1, 15, 3, and 5, but there's lots of other fractions that multiply to 15 that aren't integers. So this doesn't work either. So what we want to do is rearrange it into the form 6x squared minus x minus 15 equals 0. So what I have here is an ax squared plus bx plus c equals 0. Now, because we have a quadratic equation that is equal to 0, factoring helps us. Because when we factor, we know one of the factors will have to equal 0. Okay, so I'm looking for two numbers then that multiply to 6 times -15, which is -90, and add, sorry, just put equal, and add to -1. So hopefully you can gather that that is -10 and +9. So I'm going to decompose my middle term. So 6x squared plus 9x minus 10x minus 15 equals 0. So notice I put the 9 and the 6 next to each other and the -10 and -15 just to make factoring easier. Also, notice that I left the equals 0 here. This is crucial because we're not just factoring for factoring's sake anymore, we're factoring to solve an equation. So we need to include that equals 0 to show that we are solving an equation the entire time. So now we group first two and second terms, two terms together. So I can common factor out a 3x, and I'm left with 2x plus 3. And here I'm taking out a -5, so then I'm left with 2x plus 3 equals 0. Don't forget that. So now I have 2x, oops, sorry, don't know what happened. 2x plus 3, 3x minus 5 equals 0. So now I can solve this because I know now that 2x plus 3 has to equal 0. So then I get 2x equals -3. So x is -3 over 2. Or 3x minus 5 equals 0. 3x equals 5. And x would equal 5 over 3. So there's a bunch of different ways to verify that these two solutions are in fact the correct solutions. First thing you want to do is you want to check that the values satisfy the original equation using left side, right side. So not your rearranged equation, but your original. So remember your left side was 6x squared minus x, and your right side was 15. So I have to do two of these because I have to check both solutions. Okay, so this one is your x equals -3 over 2. And this one is your x equals 5/3. So I'm going to sub that in. Okay, and you can simply put this in your calculator using the fraction button, and you will get that this is exactly 15. Same thing here. I put in 5/3, and you will get that that equals 15. So left side equals right side in both times. Similarly, we can go to our graphing calculator. So now my left side was 6x squared minus x, and my right side was y equals 15. So I just need to go up in order to see that properly. Here it's where it is. This is the green is the parabola, and the blue is the where y values. So you see minus 1.5, that's minus 3/2, and 1.667, that is 5/3. Okay, we can also go to CAS and put in our original equation. 6x squared minus x equals 15. Add x equals, and you get negative 3/2 and 5/3. So those are 3 different ways of verifying that your solution is correct. Okay, so I would invite you to please practice these 4. Notice that the first 2 are already equal to 0. Don't forget as well that common factoring is one method that you'll have to use. And in B and D here, in both of these cases, you will have to move everything over to the left side so that it equals 0 and then factor. In this case, make sure you put the minus 8x as a plus 8x in between here in the normal order where it would go. Okay, so now after you've tried that, we're going to do 2 word problems that show you how this is useful. So the path of a stone thrown into a ravine is modeled by this quadratic relation. So let's think about what this looks like. We can see relatively easily that our y-intercept would be 84. So that means you're 84 meters into the air and they threw this stone, maybe underhanded, it went up and then hit down. Okay, it hit the water. So x represents the distance in meters traveled horizontally. So this would be like if you're looking at it on a side view, and y is how high it was. So how far does the stone travel before it hits the water? So basically that's asking, what is this x-intercept? So that is the same as asking, when is y equal to 0 for what x values? So we need to solve the equation negative x squared plus 5x plus 84 equals 0. That's what's required. It's not asking us for a vertex. It's asking us to solve this equation. So to solve this equation, we need to factor. Now notice right now, this is actually a complex trinomial because the a value is -1. But if we factor out a -1, we actually have a simple trinomial because now the a value is 1. So we can think through the numbers that multiply to -84 and add to -5, sorry. And as you explore the different factors of 84, you will find that it is x plus 7 and x minus 12. So 7 times -12 equals -84 and adds to -5. So that means my solutions are x equals -7 and x equals +12. So notice that we are not considering the distance before the rock is thrown, so we call this x value inadmissible. And that's the term to use. So this means this is the solution. So if you put x equals 12 into the equation, you would get the result that y equals 0. So therefore we can say the stone travels 12 meters before hitting the water. And I would invite you to try CAS and GeoGebra to verify your solutions. And in fact, you can use that for the other examples you did above as well. Okay, one more question. Okay, here we have a rectangle and its length and width are represented by these two expressions. So we can label one side as 3x plus 1 and another side as 2x minus 5. We're also given that its area is 1150 meters squared. So what are its dimensions? Well, we know that our area is equal to length times width, which is equal to 1150. So we can sub in our length, 3x plus 1, and our width, 2x, sorry, that should say minus 5, minus 5 equals 1150. Now, it'd be really cool if we could just set each of these factors equal to 0 now and just say, oh, it's negative 1/3 and 5/2. Well, that doesn't work because in order for that to be appropriate, we would have to have an equation that equaled 0. What this is saying is right now is that this number times this number equals 1150. So we can't actually use these nice little factors. We have to FOIL, okay? Because what we need in order to solve an equation, remember, is you need something that's ax squared plus bx plus c equals 0, and then you factor that. That's when you can solve. This is what you need in order to solve an equation. So our plan here is to FOIL and then move over the 1150. So you have an equation equaling 0 and then factor. That's our long-term plan. Okay, so we FOIL this. 3x times 2x is 6x squared. Then we have minus 15x plus 2x minus 5 equals 1150. So we'll collect like terms. 6x squared minus 13x minus 5 equals 1150. So now we need to move the 1150 over, which means subtracting 1150 from both sides. Okay, now I'm not going to lie to you, this is not fun to factor. It's pretty awful. So this is why we want to use the quadratic formula, which we'll be learning in a few days. But this is factorable, believe it or not. This actually factors to 6x plus 77, x minus 15 equals 0. Okay, so to solve this, you would set this equal to 0. So you get x equals negative 77 over 6, or you set this to 0, so you'd get x equals 15. So this answer here is inadmissible. You would get negative side lengths, which doesn't make sense. So the question asks for its dimensions. So now that I know that x is 15, I can put that into each of these expressions to find the length and the width. So the length then is 3 times 15 plus 1, which is 46 centimeters. And the width is 2 times 15 minus 5, so that would be 25 centimeters. So let's check to see if these work. Okay, so 46 times 25 is in fact 1150, so therefore that works. So I can give a nice little sentence. Therefore, the dimensions are 46 centimeters by 25 centimeters are the dimensions. Okay, again, you can use GeoGebra and the computer algebra system to solve this, especially since it is so challenging. So I can even put in my original equation. Let me see if this works actually. 3x plus 1, 2x minus 5 equals 1150. And see, I can even put it in that form, and I can verify that my answers are correct. So even if you made a mistake with foiling, you'd be able to catch it by doing it with that. So now take a look at the success criteria from today. This is what you're expected to do as a result of this note and the homework that you get from it. So thanks for watching, guys. Hope you learned lots.